Good afternoon. As the ending of the fourth unit in modulation and multiplexing for various forms of data transmission, so today we are going to see about the multiple access techniques, that is which involves the FDMA, TDMA, CDMA and DAMA assignment methods. So there are four techniques used in the multiple access techniques nowadays for wireless communication, that is frequency division, time division, space division, multiplexing. So what is the purpose of multiple access? Many users can able to use the available channel at the same time. So it is used to share the finite amount of restricted radio spectrum by millions of subscribers, other users. It will lead to high performance, and the duplexing generally needs for use to use the multiple access technique. It can be used in frequency domain or in the time domain. So here, since it needs a duplexer, let us first see the duplexing technique. So this is frequency division duplexing. So if it is frequency, we are in need of two band of frequency for forward channel as well as the reverse channel. So the first forward channel band is called as forward band, and the reverse channel band is called as reverse band. So it is needs duplexer needed. Frequency spectrum between the frequency band used for forward and reverse is constant, right? So this is the frequency band, and this is for reverse channel, and this is for forward band. And similarly, we have the time division duplexing. It uses a time for forward and reversing. Multiple users can share the single radio channel by you assigning the different time slot. So it needs two slots. One is for forward communication, the another one is the reverse communication. No duplexer is required. And there are the different types of multiple access techniques, like frequency division multiplexers, time division multiplexers, code division multiplexers, and space division multiplexers, right? So all the four multiplexers can be grouped into two major systems. One is a narrow band and another one is a wide band. So if it is a narrow band system, means large number of narrow band channels can exist. It is usually based on FDD, which is nothing but frequency domain duplexing, and it can be of narrowband FDMA or narrowband TDMA, or with the combination of duplexing technique like FDMA, FDD and FDMA TDD, or TDMA with FDD and TDD combination, right? So logical separation of FDMA FDD. So here this is the forward and reverse one. This is some FDD concept, and here we have user 1 to user n. That's why it is combined together. It is called as a FDMA FDD. So here the available resources, which is represented by the blue color box, which has been shared by many users 1 to n. That's why it is called as FDMA. And for each and every user, we have assigned two channels, one for forward and result. That's why it is called as FDMA with the FDD. Similarly, the logical separation for FDMA TDD. So here, since the available spectrum is shared by user 1 to user n, that is called as FDMA. But here each and every slot in a horizontal manner, it is shared. It is divided into two slots, right? So forward and reverse in terms of time. That's why it is called as the combination of FDMA along with TDD. And here this is for TDMA FDD. Here we have the vertical separation, right? So if it is vertical separation means TDMA, if it is horizontal separation means FDMA, right? So here the user 1 to user n has been divided vertically, and for each and every user the two channel has been assigned vertically. That's why it is called as FDD. And here this is for TDMA and TDD. Similarly, the available resources has been shared by user 1 to user n vertically. That's why TDMA. And here for each and every user, two different channel or two different slot has been assigned vertically. That's why it is called as TDMA TDD. And wideband system, there are different combinations of wideband system along with the FDMA and TDMA and CDMA. So all the multiple access has been used in combination with the duplexing technique in order to provide the wideband separation. And this is the combination of CDMA and TDD. CDMA along with the TD. So here in CDMA, by assigning a different pseudo noise random sequence, which is called as PN sequence, the n number of user can share the common available resources. That's why it is called as code division multiple access. And this is for CDMA TDD combination. Since it is here the sharing is different, that's why it is called as CDMA TDD. And these are all the already used multiple access techniques in different applications, like AMS, that is advanced mobile phone system. It is used FDMA TDD, and US narrowband spectrum 60, that is called as IS95. It uses a CDMA FDD, that is this one. And similarly, USDC, that is United States Digital Cellular, it uses a TDMA FDD concept. And frequency division multiple access technique. What is FDMA? One phone circuit per channel. Ideal term cause wasting of resources, simultaneously and continuously transmitting, and usually implemented in narrowband system, right? So the example for FDMA, it is the analog mobile phone system, that is AMS, it is a FDMA bandwidth of 30 kHz implemented. And the FDMA compared to TDMA, fewer bits needed for synchronization, fewer bits needed for framing, higher cell site system cost involved, high cost of duplex used in base station and subscriber units. FDMA requires RF filtering to minimize adjacent channel interferences. And here, what about the nonlinear effect of FDMA? Many channels use the same antenna for maximum power efficiency, operate at near saturation. So the near saturation power amplifiers are non-linear. This non-linearity causes the signal spreading, which will lead to intermodulation. Right? So intermodulation are undecided harmonics, which is called as interferences with the other channels in the FDMA system. In order to reduce the interferences, we have to reduce the C by I, that is capacity, channel capacity by interferences to be reduced, right? And by using the RF filters, which needs higher cost. So the number of channels that can be occupied by a FDMA system, it is represented by capital N, that is equal to BT minus B guard divided by BC. BT is the total bandwidth and B guard is the separation bandwidth, which is assigned in between the two consecutive channels. It is actually the wastage of bandwidth, and BC, it is the capacity of individual channel. And by using that formula, how do you calculate the number of channels? By using the FDMA, we have sample, we have calculated, and here for giving for the bandwidth given of 12.5 megahertz with each channel of 30 kHz and the channel separation of 10 kHz, we can able to accommodate 416 channels totally by FDMA. Similarly, TDMA time slot, the number of resources, number of subscribers can be assigned by using different time slot. One user per slot, buffer and burst method, it can be used non-continuous transmission, it can be used for digital data and digital modulation. And this is a frame format structure for one TDMA frame. One TDMA frame has minimum contains the three different fields, that is a preamble, information message and trial bit. And preamble, it is used for synchronization message, and trial bit, it is used for the giving the alert for the next frame to come, right? That's the meaning. And this is the original information to be transmitted by the TDMA. And the information message has to be divided into number of slots depending upon the number of user. Here the slot information frame is divided into n slots, so we can able to accommodate n number of users by using this TDMA frame. And each and every slot has the minimum field of trial bit, synchronization bit, information data, and guard bit. Guard bit, it is the frequency separation area in order to avoid the interferences between the consecutive slot. And synchronization bit, it is used to synchronize the speed of the transmission and reception. Trial bit, it is used to give the alertness for the frame to come. And here features of TDMA has been listed here. So here the transmission is first, low battery consumption, handoff process must be simpler. FDD switch instead of duplexer can be used. It can be used for high transmission data rate, high synchronization overhead, and guard slots. This is the formula which is used to calculate the number of channels that can be accommodated by using the one TDMA system. It is similar to the formula of FDMA. Only thing is we have to multiply with M. M is the number of TDMA users per radio channel. And by using that formula, we have calculated the number of channels that can be used for GSM. So 1000 simultaneous users has been assigned by GSM with a total bandwidth of 25 megahertz with the individual channel bias of 200 kilohertz. And this is the efficiency of the TDMA frame. Percentage of transmitted data that contain information. Frame efficiency is represented by here. And here this is the already we have seen the TDMA frame format. And this is a formula which is used to calculate the TDMA efficiency. And here NR is the number of reference bit and BR is the number of reference bit per reference frame, right? So this is a formula which is used, and this is the formula. So by calculating this BOH, we can able to calculate BT here, and by substituting the BOH and BT, we can able to calculate the efficiency of the TDMA, that is equal to 1 minus BOH by BT, where BT is given by this formula and BOH is given by this formula, right? Thank you.